All right, before we start using our calculators, let's make sure that they're set up in the correct mode. We want to set them up in degrees mode. Most scientific calculators have three modes, those being degrees, radians, and gradients. Okay. So to make sure that we're in the right mode, we'll simply find the mode button on most calculators and just click it until it's set to degrees. Now, on this particular calculator, the Texas Instruments T184, it's a little bit more complicated, so let's have a listen to see how that's done. When using your calculator for solving trig ratios, the first thing you need to do is to make sure that your calculator is set to degrees mode. Right now, this particular calculator is set to radians. We can adjust that by going to Mode. And we'll come down a little bit to where it says radians. Come over to degree. I'll hit enter. And as you can see up here, we are now set to degrees. Question 1. Calculate each of the angles given. Whenever we're trying to calculate angles using our trig ratios, we need to understand our inverse ratios. 1a says that the sine of m equals 0.869. Well, if the sine of m equals 0.869, then m, the angle by itself, will equal the inverse sine of 0.869. And to use our inverse sine, we go to our calculator, we type in second function, go down to sine, click sine, and it brings up our inverse sine. And we simply enter 0.869, close our brackets, and we get a value of 60.3. Question B states that the cosine of r equals 0.221. Again, if the cosine of r equals 0.221, then the angle r by itself is going to equal the inverse cosine of 0.221. To get the inverse cosine, press our second function, click cosine, brings up the inverse cosine because we pressed the second function. We enter 0.221, click enter, and we get 77.2. Question C states that the tan of angle P equals 1.344. Therefore, the angle P by itself will equal the inverse tan of 1.334. Second function, click tan, enter 1.334, and we get an answer of 53.1. Question D states that the sine of angle V equals 9/14. Therefore, the angle V will equal the inverse sine of 9/14. So press second function, click sine to bring up the inverse sine, and for this fraction, we'll put 9 divided by 14. We should be careful to close our brackets, especially when we're using fractions. Enter will give us an answer of 40 degrees. Question E states that the cosine of B equals 3/11. Second function, cosine brings up our inverse cos. 3 divided by 11. Again, being careful to close the brackets when we're using fractions. Click enter. 74.17, rounding to 74.2. Question F states that the tan of angle L equals 8 over 7. Second function tan, inverse tan, 8 divided by 7, close your brackets, enter, to give us an answer of 48.8 degrees. G states that the sine of x equals 1. Well, if the sine of x equals 1, then the angle x by itself will equal the inverse sine of 1, which happens to be 90 degrees. H states that the cosine of y equals 1. Second function, inverse cos 1, gives us a value of 0. Question I states that tan of q equals 1. Therefore, the inverse tan of 1 equals 45 degrees. Question J, the sine of s equals 0. Therefore, the inverse sine of 0 equals 0 degrees. Question K states that the cosine of t equals 0. Second function brings up the inverse cosine, entering 0, gives us a value of 90 degrees. And the last question, L, states that the tan of c equals 0. Therefore, the inverse tan of 0 also equals 0. Question number 2. Find each of the angles shown round to 1 decimal. Well, in question A, we're given the reference angle, so we can bring in our hypotenuse, opposite, and adjacent labels. So we're given the values for opposite and adjacent. So the trig ratio that deals with opposites and adjacents is the tangent. So we can say that the tangent of theta equals opposite over adjacent, and in this case, the tangent of theta equals 8 over 10. Theta by itself, therefore, will equal the inverse tan of 8 over 10. At this point in question 2a, we're left with an equation that says theta equals the inverse tan of 8 over 10. So what we'll do on our calculator is we'll come to the second function, choose tan, which will come up as inverse tan because we press the second function, and then enter 8 divided by 10, close bracket, click equals or enter for an answer of 38.65, which will round to 38.7. Question 2b, we're shown the reference angle. We'll bring in our labels. And we're given the opposite and the hypotenuse. So the trig ratio that deals with opposites and hypotenuse is the sine. So we can say that the sine of theta equals opposite over adjacent. And for this particular triangle, the sine of theta equals 20 over 25. Theta by itself, therefore, equals the inverse sine of 20 over 25. Theta equals the inverse sine of 20 over 25. Second function, sine to bring up the inverse sine, 20 divided by 25, close bracket, gives us an answer of 53.1 degrees. Given our reference angle, here are the labels. Relative to our reference angle, we're shown the opposite and the adjacent, which tells us that we'll be using the tangent ratio. Therefore, the tangent of theta will equal 20 over 13. Theta by itself will then equal the inverse tangent of 20 over 13. Question 2c leaves us with the equation theta equals the inverse tan of 20 over 13. So we'll click second function, select tan, gives us the inverse tan, put in 20 divided by 13, close our bracket, click enter, and we're given an answer of 56.97, which will round to 57. Here's our reference angle. Therefore, we'll bring in our labels. We're given the opposite and the hypotenuse, telling us that we should be using the sine ratio. So we can say that the sine of theta equals 8 over 14. Theta by itself, therefore, equals the inverse sine of 8 over 14. So we have theta equals the inverse sine of 8 over 14. Press our second mode. Press sine, brings up inverse sine. Type in 8 divided by 14, close our bracket, equals, and it leaves us with an answer of 34.84, which rounds to 34.8. Question 3, find each of the missing angles shown. Round to 1 decimal. Remember, angles in a triangle add up to 180 degrees. So we're being asked in this question to find both angle A and angle C. But because a triangle adds up to 180 degrees, and we already know that one of the angles is 90 degrees, we only have to find one of these angles and then subtract from 180. So let's select A as our reference angle. So we're looking for the opposite over the adjacent. So we can say that the tan of angle A equals 20 over 25. Angle A by itself will equal the inverse tan of 20 over 25. And when we put that into our calculator, we'll come up with an angle for A of 38.7 degrees. Now, if angle A is 38.7 and angle B is 90 degrees, then we can calculate angle C by subtracting 90 plus 38.7 from 180, which gives us a value of 51.3 degrees for angle C. Question B asks us to find angle C and angle B. If we select angle C to be our angle of reference, then that will give us a hypotenuse of 19 centimeters and adjacent of 15 centimeters. So the trig ratio that deals with adjacent and hypotenuse is the cosine. So we can say cosine equals adjacent over hypotenuse. And for this triangle, we can say that the cosine of C equals 15 over 19. C by itself will equal the inverse cosine of 15 over 19. And punching this into our calculator will give us a value of 37.9 degrees for angle C. And once we know angle C is 37.9 and angle A is 90, we can subtract the sum of those two angles from 180 to give us an angle B of 52.1 degrees. Question C asks us to find angle B and angle C. We'll select angle B to be our reference. Understand that we could have picked angle C and worked out the trig ratios for that one. It doesn't matter. I've just for my own purposes decided to go with angle B being theta. So we are given the opposite and adjacent, and the trig ratio that deals with opposite and adjacent is the tangent. So we can say the tan of theta equals opposite over adjacent, or in this case the tan of angle B equals 24 over 41. That means angle B on its own will equal the inverse tan of 24 over 41. Entering those into our calculator will give us an angle of 30.3 degrees for angle B. Once again, adding angle B and the right angle A together, subtracting that value from 180, leaves us with 59.7 degrees for angle C. Question D asks us to find angle A and angle B. If we select angle A to be our theta, then we know the opposite and the hypotenuse. So opposite and hypotenuse tells us that we should be using a sine ratio. So we can say that the sine of angle A equals 12 over 17, which means that angle A by itself equals the inverse sine of 12 over 17. Entering those values into our calculator gives us a value of 44.9 degrees for angle A. Adding angle A and angle C together and subtracting that sum of that from 180 gives us a value of 45.1 degrees for angle B. Question E, it says find the angle A and angle B. If we select angle A to be our theta, then we are given the adjacent and the opposite. The trig ratio that deals with opposites and adjacents is the tangent. So we can state that the tangent of angle A equals 24 over 11. Angle A by itself then will equal the inverse tangent of 24 over 11. Entering those values into our calculator gives us an answer of 65.4 degrees for angle A. If we add angle A plus 90 degrees, and subtract that value from 180 degrees, we get a value of 24.6 degrees for angle B. Question F asks us to find angle B and angle C. If we select angle B to be our theta, then we are given the adjacent and the hypotenuse. Trig ratio that uses adjacent and hypotenuse is the cosine. So we can say that the cosine of angle B is 15 over 17, which means that angle B by itself will equal the inverse cosine of 15 over 17. Entering those values into the calculator will give us an angle of 28.1 degrees for angle B, which allows us to calculate angle C as 61.9 degrees.